Hello boys, welcome again to our online class. At this critical condition, staying home is the best way of staying safe. I hope all of you are doing so. On our first class, we had a discussion on chapter 1. We have solved some mathematical type questions. We have discussed on different topics of chapter 1. Today we'll try to focus on chapter 2. Chapter 2 is motion. On this chapter we will try to focus on different topics that are important for your exam, and we will also try to solve some mathematical type questions. First of all, as the chapter name depicts motion, what is motion? When an object changes its position with respect to time, then it is called motion. And if the opposite one happens, that is called rest. That is, when an object doesn't change its position with respect to time, then it is called rest. If we want to tell about motion, there are different kind of motion, as you have known earlier: linear motion, translational motion, circular motion, periodic motion, simple harmonic motion. What is linear motion? The motion of an object in straight line is called linear motion. Translational motion, if all particles of the object travel same distance in same direction within same time, then it is called translational motion. Circular motion, the motion of a moving object always at equal distance from a certain point, that is called circular motion. Periodic motion, after certain time passes a certain point repeatedly. If the motion of an object is such that after certain time it passes a certain point repeatedly, then it is called periodic motion. Simple harmonic motion is a special type of periodic motion, where in a full time period the object passes back and forth. That means it passes the total time in one direction, and another time, and the rest of the time in opposite direction. Then that is called simple harmonic motion. You have seen different examples of this motion on your book. There are so many examples of linear motion, translational motion, circular motion. You have to know all these examples and the definition as well. You have to know the definition for your knowledge-based question, and you have to know the examples for MCQ type question. Okay, these were the different kinds of motion and their examples. You should follow the book with examples. Next, you have known about scalar and vector quantity in this chapter. The quantity that can be divided into two parts, scalar and vector. The scalar quantity is what? The quantity that has only magnitude is called scalar quantity. For example, mass, time, etc. Sorry. Another important thing about scalar quantity is scalar quantities follow normal algebraic rules. That means if I want to do addition, subtraction, multiplication, etc. using scalar quantities, that will follow normal algebraic rules. But if I want to say about vector quantity, then what is vector quantity? The quantity that has magnitude and direction is called vector quantity. That means to measure a vector quantity, we have to know about its magnitude and as well as the direction. And for example, velocity, acceleration, force, etc. are examples of vector quantity. Vector quantities doesn't follow normal algebraic rules. That means for subtraction, addition, multiplication, division, there are some special rules for vector quantities. You will know the details of these rules on your HSC class. Okay, on your higher studies you will know details about vector quantities and their rules. Then you have known about distance and displacement, the difference of distance and displacement. First of all, distance is a scalar quantity and displacement is a vector quantity. That is, distance is not involved with direction. If an object passes a certain path within a certain time, that path is called its distance. But if with distance we add the direction, then that will be the displacement. That will be called displacement. Distance toward a certain direction is called its displacement. Okay. Then speed and velocity. What are the difference of speed and velocity? As we have known about distance and displacement, speed is also a scalar quantity, but velocity is a vector quantity. What is speed? If we divide distance with time, that is called speed, and velocity is displacement divided by time. Then we will try to know about acceleration and deceleration. What is acceleration? If the velocity of an object rises with time, that is called its acceleration, and deceleration or retardation is the opposite of acceleration. What is deceleration? The velocity reduces with time, then it is called and we just divide the velocity by the time, that will be called deceleration. As you have known about acceleration, velocity, now you can explain one thing, that explain why a body moving with uniform velocity doesn't have acceleration. And to explain this one, we have to know about uniform velocity. What is meant by uniform velocity? If the velocity of an object doesn't changes with time, that is called uniform velocity. Then how can we explain this term? For acceleration, as we have known that if the velocity changes with time, that is called acceleration. That means for having acceleration, an object have to change its velocity, and as velocity is a vector quantity, it can be changed by two ways, either changing the magnitude or changing the direction. But in terms of uniform velocity, the magnitude or direction, none can be changed. Both terms remain same, so there is no chance of having any acceleration. So that's why we can tell if a body moves with uniform velocity, it doesn't have any acceleration. Then in this chapter, one most important thing is equations of motion. We have known about motion, different kinds of motion. Then we have to know about equations of motion, because these equations will be used in mathematical type questions as well. I also want to add one thing here. This chapter, that is chapter 2, motion, is a very, very important chapter for any kind of exams. That means for school exams or board exam, for any kind of exams, chapter 2 is a very, very important chapter. So you must focus all topics of this chapter, and you must practice the creative type questions as well. Okay, as we were saying, equations of motion, generally there are four types of equations here, and these equations are given by or discussed by scientist Sir Isaac Newton. He first discussed about this equation. Okay, our first equation relates between distance, velocity, and time. What is the first equation? Equation of distance with uniform velocity is S equals Vt, where is the total distance, V final velocity, and T the time. T represents the time. Our second equation is about the equation of final velocity with uniform acceleration. What is the equation? V equals U plus AT. We can represent this equation in another way. V is proportional to t. How can we write that? If the object starts from rest position, then initial velocity u on this equation will be 0. Then the equation will become b equals at. As we are telling the acceleration is uniform, that means constant, then we can write b is proportional to t. That means what this line represents, what information we can share from this line. The relation of velocity of an object moving with uniform acceleration and time is proportional. If an object moves with uniform acceleration, then the relation of velocity and time will be proportional. We can show it, we can solve it, we can prove it. If comprehension based question comes, we can write this for that type of question. Okay, third equation of distance with uniform acceleration. Here we are again using uniform acceleration, but the relation will be with distance. The equation of distance with uniform acceleration is s equals ut plus half t square, where as distance u initial velocity, t time, and a is acceleration. Again, if the body starts from its rest position, then u will be 0, initial velocity u will be 0. Then this equation becomes s equals half t square, as a is uniform acceleration. This is a constant term. We can write from here s is proportional to t square. This represents the relation between distance and time. If it moves with uniform acceleration, that means if a body moves with uniform acceleration, the relation between distance and time will be square proportional. Our last equation, our fourth equation, is the relation of initial velocity, final velocity, and distance with uniform acceleration is d square equals u square plus twice as, where v the final velocity, u initial velocity, a acceleration, and distance is s. If the body starts from initial rest position, then we can write u equals 0, and then v square equals will be twice as a is uniform acceleration or constant, then we can write v is proportional to root s. That means if a body moves with uniform acceleration and it just starts from rest position, then the relation between final velocity and distance will be square root. We have seen 4 equations of motion and their explanation and some special terms from this equation. We have to know about this equation. We have seen that with uniform velocity there is only one equation with uniform velocity, that means s equals vt, and the rest of the equations are with uniform acceleration. For multiple choice question, we have to know these equations, these relations, and for comprehension based question, we have to know the different format that we get from this equation. That means how is v is proportional to t, how is s is proportional to t square, or how is b is proportional to root s. We have to know about this term. Then we will know about laws of freely falling bodies. These laws are given by scientist Galileo. To implement the laws of freely falling bodies, we have to maintain two conditions here. First condition is the body will fall from a rest position, from a fixed position, and the second condition is the body will fall freely. That means no resistance will work here. If a body starts from a starts falling from a rest position, and if no resistance works here, then we can implement three laws here, three laws of freely falling bodies. The first law is, starting from rest position, freely falling all bodies will cover the same distance within same time. If all the bodies starts from same position, from their rest position, and if they are let to fall freely, then they will cover the same distance within the same time, and it will not vary with their mass. That means the time will not vary with their mass if they are fallen freely. Second law, if we want to tell about second law, for freely falling bodies, the velocity is proportional to time t. If the freely falling bodies just cover a distance within time t, and if their velocity is v, then the relation between velocity v and time t is proportional. The third law is, for freely falling bodies, the height covered by the object is square proportional to the time. All the bodies that are fallen freely, the total height they cover, that will be proportional to square of time. So these are the laws of freely falling bodies. We will implement these laws in our mathematical type question. Actually, the laws of freely falling bodies are the implementation of laws of motion, or the special form of the equations of motion. So in this chapter, if I want to review again, we have known about motion, different kinds of motion. You have to know the examples of every kind of motion. I repeat, you have to know about the definition and the examples as well. Then you have to know the difference of scalar and vector quantity. For your question, if comprehension type question comes, then you have to differ about scalar and vector quantity. You have to know the difference of distance and displacement. We have known about speed and velocity, their difference, and you have known about acceleration and deceleration. What is uniform velocity? Equations of motion. You have to focus on this term very carefully, very attentively, because equations of motion is a very important topic for creative type questions. And last we have discussed about laws of freely falling bodies. I hope you have understood all the topics as you have studied earlier on your regular class, and on our next class we will try to solve some creative type questions. On my previous class I have given some work to you. I hope you have completed this works, and you will submit your homework on the comment box, including your roll numbers, and just try practicing at home as you are getting enough time. So just utilize it properly, so that you can do better result on your board exam, SSC exam. Okay, boys, that's all for today. Stay home, stay safe, and just stay with your education. Okay, see you next. Okay, goodbye for today.